last section, we discussed how you maybe can find a derivative of a function when you don't know its exact formula using implicit differentiation. Today we're going to talk about another way we can find the derivative of a function or a variable, but this time instead of using implicit differentiation, we're going to use what we know about other variables or other derivatives. And so let me write a quick example on the board and we will discuss it. So in this example, we're going to say that y equals 2x plus 7 and z equals y squared. And then we want to find dz by dx. So in this case, as you notice, we only know z as a function of y, but we do know y as a function of x. And so what we can do is there are a couple different methods. And the first one I'm going to discuss with you here is we can use substitution. And so we can actually say then that z equals 2x plus 7 squared. And then we can use the chain rule to find this derivative. And so, of course, dz by dx would be 2 times 2x plus 7, all times the derivative of 2x plus 7, which is 2. And so this would be equal to 8x plus 28. Okay. And so that's one way, and that's using strictly techniques that we've already seen. But one of the nice things about the first derivative is that, as we see, it's written as a fraction here, dz divided by dx. Well, for first derivatives, and this doesn't work with higher order derivatives or with partial derivatives, but for first derivatives, we can actually treat it the same way we would a fraction. And so we can say dx by dz is equal to 1 divided by dz by dx. All right, so we can do things like that. We can also do things like dz by dx equals dy by dx times dz by dy, because these would cancel just like they do in fractions. And so what most of the related rates section is using these properties to find derivatives of things that maybe we don't have the exact formula for the function as a function of the variable we're trying to find its derivative. And so we use related derivatives, and that's why this is called related rates. And so this time I want to redo this problem that we were working on before, but use this method right here. Okay? So then the first thing we need to do is we need to find dy by dx and dz by dy. Okay? So with this being y is 2x plus 7, so dy by dx is equal to 2. Okay? And then since z is equal to y squared, we know dz by dy, that's equal to 2y. Okay? And so then when we come over here, this here is equal to 4y. But now we have a problem, right? Because we were asked to find dz by dx. This should be a function of x, and we have a function of y. So then our final step is actually to replace y with the formula for y in terms of x. And so then this would equal 8x plus 28. And so that's how we go about doing that problem using this method. Okay? So then the next thing I want to do is I want to work a couple other examples that will require different methods. And so for our next example, we're going to be given y equals x squared plus 2x plus 1, right? And then we're going to be told dz by dy is equal to 3y plus 7. Okay? And then in this case, so what I want us to find is what is dz by dx. Okay? So using the method from the previous portion, we know that we can, if we find dy by dx and multiply them, we'll actually get dz by dx. And so let's go ahead and do that. So dy by dx is equal to 2x plus 2. Okay? And so then we multiply these pieces together. And so then we know dz by dx equals dy by dx times dz by dy, which is equal to 3y plus 7 times 2x plus 2. Now we have one last step. We do need to rewrite y in terms of x. And so then this is equal to 3x squared plus 6x plus 10 times 2x plus 2. And then from there we can FOIL it out, but now that we're at a function of x, this would be a satisfactory solution to turn in. All right? So this is just another example of what related rates looks like. And for your problems, you're going to be expected to kind of intuit out which pieces you're going to need and which pieces you're going to use. All right? So make sure to attend office hours, ask your instructor, and practice these problems, because there are many variations on how a related rates problem can look. Right. Well, next time we're going to start looking at functions of multiple variables. So I look forward to seeing you then.